Okay, hi. Okay, hi guys. This is a video recording on how you will approach a titration curve question. Okay, generally, essay-based questions can be very tedious. They can be very difficult. But if you know what to do at different parts of the questions, they can become very, very easy. So I'm going to give you an example question. What you're going to do is that you are going to take a piece of plain paper or foolscap paper, copy down the question, and we are going to do this together. Okay, now this is the question. It is going to be a titration curve question. And they are going to tell you that ethanoic acid is going to be titrated against NaOH. Okay, and they are going to give us some information about this acid at this base. First is that they are going to tell us about the concentrations. So the concentration of the acid is, let's say, 0.1. Okay, 0.1 moles per dm3. The base is also the same. And the volume of the ethanoic acid is given. Okay, it's given to us as 25 cm3. Okay, so these are the information given. Now, when you get a titration curve question, you must understand what you are doing. When we say ethanoic acid is titrated against NaOH, you must know who is being added to what, because that makes a difference. That means whatever thing that you see in front, something against something, the first thing is the species that is already inside the conical flask. The second substance after the word against is the one that is being added drop by drop into the conical flask using a burette. So it's an experiment you've done since secondary school. It is just that you are adding NaOH into a bottle of ethanoic acid. Now, in a titration curve question, the setup is very simple. What we want to do is we want to draw a curve. And in this curve, the y-axis is the pH. Now, what is it a pH of? The pH of the solution in the conical flask. That is what the pH is. Now, the x-axis is basically volume. It is the volume of the second substance being added. So in this case, it is volume of NaOH added. Okay, so this is a graph that we are trying to plot. And in a titration curve question, you have 4 major regions. And our goal is to cover these 4 major regions and for you to become experts of these 4 major regions. Now, the first major region is called the initial point. And the initial point is very easy because the initial point is basically the beginning of the experiment. Now, you see, it matters who is waiting in the conical flask. Because if ethanoic acid is in the conical flask, it is acidic. The initial point should therefore be at a very low pH. But if I flip the question and says we are titrating NaOH against ethanoic acid, then you must realize that it will be NaOH that is inside the conical flask. The initial pH will therefore be very high, very alkaline. But for this question, it is ethanoic acid that is in the conical flask. So we are going to start at a very low point. Now, at the initial point, what we are going to observe is that we are going to calculate the pH when there is 0 NaOH being added, which means it is just a beaker of ethanoic acid, correct? And that means all you need to do is to calculate the pH of 0.1 moles per dm cube of ethanoic acid. Usually in a titration curve, the Ka is given. Either the Ka or the Kb is given. So let's write this down. The Ka of ethanoic acid is also given in the question. Okay, it is 1.8 times 10 to the power of minus 5. This is the Ka value. Now, the first initial point is all you need to do is to calculate the pH of the ethanoic acid. So we are going to follow the technique used to calculate pH of weak species because ethanoic is weak. I say countless times, go and write the ethanoic acid dissociation equation. It is a weak acid, so it will partially dissociate to donate the H+, and it will give us H3O+. This is our first step. The second step is to draw the ICE table. And our ICE table has a row. And the purpose of the ICE table is to be able to calculate the H plus concentration. Why? Because pH is negative log the H plus concentration. So you need the H plus concentration to solve for pH. So this concentration, this ICE table has a purpose, and that purpose is to solve for the H plus concentration. So the ICE table need to be in terms of concentrations. Do we know what is the ethanoic acid concentration? We do. So I'm going to put in 0.1. Water doesn't matter to us. In the original solution, there is no ethanoic and no H plus yet. So they are 0. Now, ethanoic acid is a weak species, meaning a certain amount will dissociate. And we don't know what is this. So we are going to make that amount the unknown, and it's called X. But since we know that they are on a 1:1:1 ratio, if this dissociates by minus X, the other two will be formed by plus X, which will give us the equilibrium values as 0.1 minus X and X and X. Now, whenever you get to this point, the next thing you should get in your head is to use the Ka to solve. Now, remember, Ka is products divided by the reactants. So in this case, our products are the ethanoate and the H3O plus divided by the ethanoic acid concentration. Now, guys, Ka is in terms of concentration. And since everything is in the concentrations, we can already put them in. Ka value is given, so I'm going to bring this back. X values are on top. 0.1 minus X is at the bottom. So what we're going to do is we are going to solve this to give us what is X. You must remember that X is the H plus concentration. If we solve X, you can solve the pH. Again, I said before, we are going to assume that 0.1 is going to be much, much bigger than X because this is a weak species, and that means that the amount that it dissociates must be much, much smaller than the original amount. So that means that 0.1 minus X is just approximately 0.1. So this will allow us to solve the equation without using quadratic equations. So you put that in, 1.8 times 10 to the power minus 5 equals to X squared divided by 0.1. If you solve for X, you can find out what the H plus concentration is. It will be 1.34 times 10 to the power minus 3. You put into the pH formula, you will get 2.87. Okay. So this is the pH of the original solution of ethanoic acid, and that is our initial point over here. Okay, so that is the first step. The first skill is called the initial point skill. And the initial point skill is very easy because all you are doing is you are calculating the pH of weak species. Okay,